In this lesson, we're going to simplify radical expressions using the product rule. Now, the product rule for radical states that if your radicals are being multiplied and they have the same index, meaning the same root, that you're simply going to multiply the inside with the inside. Okay, because that rule allows you to be able to multiply radicals, and again, that's only if they have the same index or the same root. So for example, in the first example, the square root of 2 times the square root of 32, both of those radicals are square root, so you can multiply them together. Now, what if one was a square root and the other was a cube root? Then you could not multiply them using the product rule, but you can multiply them because they are both square roots. So all we have to do is multiply the inside with the inside. So 2 times 32, which is 64, so we're going to have square root of 64. And then we can go ahead and solve. And what is the square root of 64? Yes, it's 8. And so you're done. It's as simple as that. But again, we can apply this rule when the indexes are the same. So in example 2, if they have the same index of 3, they're both cube root. So we're just going to multiply the inside with the inside. 3 times 27, 3 times 9, which is going to give me 27. So we have the cube root of 27. And now we can go ahead and solve. What is the cube root of 27? Yes, the cube root of 27 is 3. Let's do some more practice using the product rule for radicals. Now, if you have variables involved, you have to remember the product rule when you have variables. If the base of those variables are the same, keep the base. And what would you do with your exponents? Do you recall? Yes, you're going to add them together. So anytime you have variables that are being multiplied and they have exponents, if the base is the same, keep the base and add the exponents. So let's take a look at example 1. In terms of the indexes, they are the same. They both have an index of 2, which means both of them are square roots. So we can go ahead and apply the product rule. Multiplying the numeric part, 8 times 2 is 16. Now let's work with the variables. They both, for the base, have a base of y, so we keep the base of y. We're going to add those exponents. 3 plus 1 is going to give me a total of 4y. So what I'm going to have is 16y to the 4th power. And now we can go ahead and solve it. The square root of 16y to the 4th power is what? That is correct. It is going to equal 4y squared. Now, if you have forgotten how to find the root of variables, then you'll need to watch, I believe it's video 10.2, and I cover in that video how you can find the root of variables. Okay, both perfect and non-perfect variables. All right, so moving on to the second example, we look at the indexes. The indexes are the same, 3, which means both radicals are cube root, and it is okay to apply the product rule. Multiplying the numeric part, the number 5 times 25. And then for the exponents, the variables rather, the base is the same of a. Keep the base of a and add the exponents. So when I do that, it's going to leave me with the cube root of 125, a to the 15th. And now all we have to do is find that root. And this is a perfect cube root because the cube root of 125 is 5. And the cube root of a to the 15th is a to the 5th. So your answer is 5, a to the 5th.